Welcome to Coding Adventures. We are continuing our series of coding lessons for beginners with a new episode. And today we are talking about arrays. And I actually built this image using the program that we built together last time. So let's get started. Alright, so we finally reached the episode where we are discussing about arrays. And arrays are one of the most important data structures in programming and in computing in general. And of course, on our in our course of coding lessons, we have to talk about arrays. They are essentials in building fun animations, interactions, and games. So let's get started. But before we actually write any code, let's switch to the notebook and understand what arrays are. So that will basically give us a much better idea how we can utilize them. Okay, so here I'm on my notebook and I'm gonna attempt to draw an array. That will be kind of difficult. Array is a data structure, but basically at the end of the day an array is nothing else than a list. So I'm trying here to represent some sort of a list. And as with any list, we can keep multiple things inside it. So I build a list on horizontal here, and kind of I divided this list into cells, into 1, 2, 3, 4, 5, 6 cells. And basically, when we're gonna encode this into the program, this will basically be an array. And exactly like we have here on paper, a list, an array, it's exactly like that also in the program. It's a list of different things. Each of these cells can contain different kinds of data. For instance, it contains numbers. Until now we learned about numbers. It can contain strings. It can contain more numbers, decimal numbers. It can even contain other lists, like this one, all embedded inside. And inside this list also can have numbers and strings and so on and so forth. So as you can see, is basically all this before we used to load them in variables. So they are like multiple variables, one after the other. So we can even, and the entire thing, we can actually refer it to a variable. So for instance, we can say let AR and equal this array. And this is not the right way to actually encode it in the code. But what I want to say here is that the entire list of things, we can refer it to a single variable. We know that using let, we can define variables and assign things to it. And then later on, we're gonna see how can we access this individual data within these cells and even to change this information. And you may wonder why arrays are important. Well, if we want to keep multiple things of the same size, the same type, or not even the same type but related, we need an array. Let's remember, for instance, this program that we built together last time. In this program, we had 3 cars, and because we had 3 cars, we had to define 3 separate set of variables for each car. We have to define a variable for each car, and then the speeds in different variables. And you know, if we want to extend it and add multiple cars, we can basically define more variables, but it will be practically impossible just to define variables at runtime. So if we want to press a key and if we want to add a new car, we'll not be able to add a variable into this program. On the other hand, having, let's say we simulate those cars in an array, that will be much easier because we'll be able to, you know, in the first cell keep the first car, the second car, and so on and so forth. So we can have as many cars as possible. So we'll start with a few examples first using the arrays and then progressively go into more complex examples. But when we are looking at this array, let's understand what we want, what are the most common properties that we want to basically access via the code. So first of all, we'll be interested in defining an array, and we'll see today how to define an array. So in other words, how can we basically this structure put it in a proper JavaScript code? Then we are also interested into how to read various elements. So basically how to read elements. Also an important operation. We need to know, well, what is the value of the third element in the array AR? That's the proper way of saying things. We are also interested how to write elements in the array. Perhaps this represents the speed of a car or something like that, and we want to change it. We need to know, understand how to change it. Also, how can we obtain how many elements are in this list? When in other words, the length of an array. The length of the array is basically gives us the size of this array. So these are pretty important operations that we need to basically know just to get started with arrays. And then there are also other operations that they are also very important, such as how to add additional elements into array. So perhaps not when we edit the program, because when we're gonna edit, it's very simple to go there in the code and eventually add new elements, but we are interested how can we add new elements at runtime, and of course the opposite, how can we remove elements? That's also very important, because if we are able to do this kind of things, we'll be able to manipulate the array in all sorts of ways at runtime and so on and so forth. So and there are also other operations that may become useful, such as how can we find an element in an array. Is this, if for instance in an array, since the array is list, maybe we'll keep a phone book, and we are interested to locate quickly the phone number of a person. So anyway, we'll take them one by one, and we're gonna try to uncover how can we basically define the array and then to basically manipulate it or access the various properties of the array in order to achieve this kind of operations. All right? All right, I think you are excited. Too much theory. Let's get some coding going. So first thing on the list, we need to understand how to define an array. And let's take it simple. I'm saying let an array, we can refer it in a variable. So I'm picking a variable. Just by convention, I'm as for a generic variable, I'm picking AR, but as with any other variable, you can pick whatever other name, and it's good to pick a suggestive name. If this is an array of cars, maybe name it cars or something like that. But for now, this is a generic array, so I'm choosing AR. And let's say I want to have a list of numbers, perhaps the numbers from 1 to 10, like these numbers, right? 7, these numbers. How can I put them in an array? If I just type them like that, I'll get an error here, because this syntax is not recognized by JavaScript. But it's not far from this one, actually. All we have to do is to enclose these ones in square brackets, just like that. Simple, see? So in this moment, let's analyze the syntax again. We defined an array, and this array has these elements. As you can see, to define an array, you basically place the elements in between square brackets separated by comma. If we just want an empty array, let's choose another array here, name it AR0. This is an empty array. You just put square brackets. This array doesn't contain any element. Perhaps in some cases, and actually in many cases, we can just start an array empty and then we add elements into it later on when the program runs, right? But for this example, we'll just start with an array that has some elements into it. This one. Let me erase this one, not to confuse you. We'll get a chance later on to play with empty arrays. So now we are interested, well, as we can see, each of these elements of an array, they are numbers. Normally, and until now, we had these numbers in separate variables, such as maybe we had let x equal 1, or maybe x1 equal 2, x1 equal 2, x3 equal 3, and so on. This is what we did until now, right? But with an array, we don't define variables for each an individual element. Rather, we have only one variable for the entire list, and then we can say, I want the third element in this list, right? And to do that, let's obtain it in a variable, the third element, shall we? So let's say element equal AR, and to get the third element, notice here the notation. We put AR, the variable itself. If we just put it like that, we don't do anything but actually assigning into element the variable AR. So we are kind of have another reference to the same array. Element and AR will be the same. But this is not what we're intending. We are intending to get a particular element, and I mentioned the third one. So in order to do that, we have to put square brackets again, which somehow, they are the same kind of square brackets like here, so should remind you of an array. And now we should put the index of the element, and I mentioned the third element, and watch for a surprise. I'm typing now. This is the third element. Well, because JavaScript is funny. And not only JavaScript, but it's a common practice in many programming languages. As a matter of fact, in a whole range of family of languages, arrays and other data structures to start index it at 0, exactly like coordinates in a sense. So basically this is element 0, this is the element 1, and this is the element 2. So when I said I want the third element, I meant this one. So we have to basically, because it's 0 based, the array is 0 based, we have to index it with 2. And now what we can do, we're gonna print it just like that. And if we run this program, we get the number 3. Because on this third position, or at index 2, we have number 3 here, which is good, right? Now, notice one similarity with the functions. Functions, when you invoke functions, you use round brackets. When you see, and if you see this kind of syntax in the code, just know that it's a function invocation. However, if you see some sort of a word followed by square brackets, know that it's an array, it's not a function invocation, right? Even if this array would have been named something very similar to a function, it's still, if you put square bracket, it means it's an array. All right, so this is how we access number elements in an array. Let's access a couple more. And actually, we don't have to take them in separate variables. We can just, access them like that. This is the next one. And so on and so forth. Let's access a couple of them and print them. So we should see 5 numbers here printed. See 3, 4, 5, 6, 7. We took them in consecutive order. So we get all this range of numbers. So see, it's pretty easy to access an element inside an array. Now let's do, rather than actually printing these elements one by one, let's make a for loop, because we know loops are very good at just cycling through a range of things. And let's print all the elements of the array on the screen. So how can we do this for loop? How can we do it? First of all, we can leave this one for the moment. Or actually, let me put it, something like that. How can we basically print all the elements using a for loop? Well, let's start the for loop and we'll see. We have an I, it starts at 0, I less than what? And here comes the question. How can we know, supposingly that we want to iterate and somehow print each element, how can we know where to stop I, basically? And the answer is simple. I'm gonna type it and then we're gonna discuss. I'm typing here ar.length and then I++. And inside the for, I'm putting println and ar of I. So notice ar of I, nothing new here, is the same as above. And by looking at the for, we are hinting that we want to loop with an I variable that goes from 0 to somehow length of the array, this being the index, and then we want to obtain the value in that particular cell indicated by the index. Let's run it. perhaps we should comment out the previous code, not to confuse us. Let's run it again, and we see all the elements. So let's look again here at the syntax, ar.length. This is kind of a funny syntax. It's for the first time we see kind of this notation. We would have expected, if we want to obtain the length of an array, to have a function such as perhaps len of ar. This is what we've been accustomed until now, to use a function with a variable inside and obtain some data about that variable. But unfortunately, this is not the case. In JavaScript, we don't have this function. What we have instead, we have what is called a property. So we are putting the variable dot, no spaces, and then the property, and the property is called length. It's a different syntax. For now, you'll just have to kind of replicate it as you can see it here on the screen. Each time you want to obtain the length of an array, just say ar.length or ar, whatever is the variable name. If your array is named differently, just say, put the variable dot length. Later on, we'll see that these properties are actually properties of objects, because arrays are actually some objects. But for now, we don't want to go into that theory of objects, just kind of replicate this syntax. All right, and we can even look, we don't need a for here. Let's look at that property independently. We can have a println, and we need quickly to obtain the length of the array. It's ar.length, and if we are running it, we see it's 10 because we have 10 elements. Let me add another element. Let me add a string, because we can have any kind of data in an array. We should get 11. So this is basically a way to obtain the length of an array, and it's commonly used with fors, for loops that I put it here. If we want to basically obtain an element, we can use a for, a variable with a for, to cycle through some numbers from 0 till the last one with step 1, because we want to get all the elements of the array, unless we'll skip elements. So here it's most of the times plus plus, and then we are accessing the elements using the indexed notation, exactly like you access them above. All right. This is very useful, and we'll use it a lot of time to access the elements of the array like that. Before I'm moving and show you how to modify the elements of the array, let me show you another form of for. There is another, with arrays, for also takes another form. So let me put here a println, perhaps just a space, just to separate the things, and I'm gonna type a new for structure. Watch it carefully. And here I'm putting println of L. Let's run it. And we see the same result twice. This is the first for, the one that we are accustomed to. This is the second one. So the second one is even simpler to type. And this is the reason this for exists. It's a special form of for that works pretty well with arrays and other data structures, but right now we are discussing it with arrays. It lets us iterate really quickly to the elements of an array. We don't have to access the elements by index. We don't have to define any index. Instead, we are using this syntax saying for, we define a variable, whatever we want the name to be. For instance, I name it EL from element. For element of array, and this is the syntax. You choose a variable that represents the element, and then you use the keyword or, of, and then you actually put the array. And in this moment, EL contains the actual element, and for will repeat since it's a repetition, and in the next cycle of for you'll get the next element, and so on and so forth. That's why putting here print ln of EL, I'm printing the same thing as above, but in a much simpler form, right? Sometimes you'll also need this for when you iterate the arrays, but we'll see when you need this one and when you can just do the work with this one. All right, so this is about, we learned until now how to define an array, how to obtain its length, how to read its elements, even how to iterate through all the elements of the array in two different ways. So many information in this small snippet of code. So let's see now perhaps how can we change the value of an element. And I'm gonna leave these structures in place to print the arrays, because at the end of the day these ones are printing the arrays, as we can see here. And let me go in front of them and change an element and try to print the arrays and see if there is any difference. So let's say this element or this one. So what will be the index of this one? Well, first of all, we need to know the index in order to change this element, and this index should be 7 because it's 0, 1, 2, 3, 4, 5, 6, 7. So it's 7. Actually, let me put the indexes above. It will be much easier for us to refer to them. I'm putting like a comma. So this is index 1, 6, 7, 8, 9, and index 10. See? So let's say we want to modify the index 7. All we have to do is say array, and we use again the index notation, index 7. But instead of reading it, instead of taking it in a variable such as this one, we are actually assigning it, exactly like we're doing with variables. And let's assign to this element a new value. And we can put a string in here. Again, in JavaScript, in arrays, you can mix data types. You can put numbers, strings, even other arrays, as we'll see in a moment. And it's just fine. So let's have this statement before we're actually printing, and let's see if we notice any difference. Run it. Sure we have. Look here. This element has been changed and now it has value 0. Yeah, or hello. As a matter of fact, let me show you something. When we are printing these elements, and you'll notice in a second the difference between these two four structures, let me print also the index so we'll see it clearly. So this is I, and perhaps here we should put a notation like that. And this is the element. Now here we don't have access to the index, or not, at least not in an easy way. So therefore, each time when we need to have access to the actual element, but also the index, we can use this kind of for. So now let's run it. The same, see, this one also displays with the index in front, so it's 7, it's hello. Or we can display, you know what? We can also display something like this. AR of this value equal, and if we run it, it will look like the elements in the code, but it's just pure display operation. We just typed AR, we printed AR. It's a simple trick, but looks probably better than just listing the index directly. All right, so we know now also how to modify the elements of an array. What can we do? Yeah, removing an element. We can remove an element at an arbitrary position by index, basically. We also need to know the index, but it's very common in JavaScript, and not only in JavaScript, but in programming, to remove elements like especially from the end of the list or sometimes from the beginning of the list. So let me show you removing from the end of the list. JavaScript, there are also, like this AR.length, some operations that can be applied to the AR array or AR kind of array object that will basically remove or add elements at the end of the array. Array is behaving in this way like a stack. We put on top of the stack, this being the top, and we remove from the top of the stack. Actually, that's the kind of term. You can simulate stacks with arrays in JavaScript. So therefore, even the operations themselves will be called, if we want to add an element at the end, it's called push. We are pushing to the stack, and to remove it is pop. So let's see this in action. So perhaps we should go here before we are printing the elements. And let me actually comment out the second one, just to have them neatly, just one single print. All right. So I'm gonna go there, also separate them a little bit with a comment. And first of all, let's remove ABC. And the way we do is say AR pop, just like that. We use the same dot notation like that we used with the properties. We say AR pop. Notice we don't do pop of AR. This would have worked if pop was a function that accepts an AR as argument, but we don't have pop as a function. We have it here like it is called like a method on the array object. But it looks like a function basically. It's just the way you invoke it, you just put the variable before it and you put a dot and then you use the function. So let's run it and we should see again the array but without ABC, which we do. And you know what? When we are removing it, actually we can also read it in a variable. So it's possible to take it in a variable like that. And now X will be ABC. If we don't use the variable, you know, from the array is already removed, but we can read it in a variable. Anyway, we are not interested in this aspect right now. Let's push a new element. Instead of that ABC, we can push an XYZ. A different string. Let's run it. And indeed, we have an XYZ here instead of that ABC. So we remove the last element and we added one there. All right. What about removing at an arbitrary position? So for instance, perhaps we want to remove this guy over here, which is index 9, right? So number 10 should disappear if we remove it. It's basically use the function splice. We should put index 9 and then the second argument means how many elements we plan to remove. And if I run it, see, we don't see 10 anymore. So splice, I'm using it in the same way as push and pop. I'm passing the index and how many elements I want to remove. Actually, splice is a more complex function, takes also other arguments, but you know, just using it in this form is very common. Many times we have to remove only one element. So therefore, we use it passing the index and then 1. That's it. If you want to remove 2 elements, put here 2. But most cases, it's 99% of the cases in the programs, we just need to remove 1 element. Therefore, it has this form like this one. Right. Now, let's run it again. Okay, it looks fine. What about now? Let's place, no, it's fine. Let's remove the element. Let's say we have a problem where we want to remove an element that basically, let me put a comment here for people on the chat. So maybe I should comment this one. Adds an element at the end of the array, and let's say this one removes element at index 9. Okay, and now the question is, let's say we have a program and we have inside the program lots of data. Perhaps this data is wrong. Instead of these 2 here, we'll have an I don't know, maybe we'll have a different number. We have a 0. All right, let's say this array captures some measurements that we made, and we have to clean up the array and we have to remove the element that has the value 0. All right, so here in the function 1 stands for how many elements we want to remove, Pavel. So let's now remove an element for which we know the value, not the index. How can we remove an element if we know its value, not index? Let's eliminate this 0 from here. We don't know that that element is at index 1, because if we don't know, we just use this form, right? So the way we're gonna do it, we can do very easily by looping on the array and then check each element like we did here. We check the value, and if the value is 0, we're gonna use the splice, right? Sounds good? Let's actually save this one. Simple, let's say array basics. We'll save it. Just in case you need it, I'm gonna place it on the chart, but it's just simple things. So array basics. And it's much nicer to start a new program just to have a clean code. And let's have another array really quickly with those numbers 1, perhaps 2, 3, 4. Let's have a 0 here, 6, 7, 8, 9, 10. That's it. So just to display it, we'll loop through it of AR, and we're gonna just println of element. So we're gonna display it, and now, yeah. So let's have the task remove elements of value 0. So let's do it. We have to iterate through the elements. We're not gonna use this syntax this time. We're gonna use the one with the index notation, because we need splice takes an index, and if we are using this one, we cannot provide an index. So let's loop through the elements. But here it's a trick. If we want to do this kind of, to remove an element, knowing its value, and we are looping, and when we are looping, we try to remove it, the trick consists in the fact that we have to loop them backwards, not in this direction like we did last slide. And why is that? Is because if we loop the array in this direction, and once we encounter this element, we're gonna remove it, all the other elements following will just come forward, will kind of, or in other words, the array gets reindexed, right? So the array gets reindexed, and we actually encountering there one extra elements. It's just not good. In certain cases you may get an error, in other cases you may not notice the problem, but just remember this. If you want to remove an element by using splice inside an array, inside the for, loop backwards. So let's do that one. So we're gonna choose a variable. This time the variable starts at AR length -1, right? Because if there are 10 elements in the array, the last position is -1. It's index 9. I greater than 0, I minus minus. We just loop backwards. And here, first of all, let's print them just to make sure that we loop them correctly. Save. So we see the looping till here, and after this point is the other loop. So yeah, we are looping correctly to the elements, but we are not intending to print them. We want to remove an element. So we're gonna compare them. If AR of I equal to 0, and here we'll do the splice. We're gonna splice at index I one element. This number stands for how many elements we want to remove. All right. So let's try it. We still have it there. Let's see. Oh, right. AR.splice. And now we don't have a 0 here. Right. So I can also do the looping in the other direction and show you that we may get a small side effect, but you can also just do this test for yourself and print in this time. But it's just remember, if we want to remove an element, remove element in for. I'm gonna name this one, remove elements of value 0, looping backwards. Okay. So let me put this small snippet in the chat as well. Remove elements array 4. All right, that program is also in the chat. And what else? Let me go back to the one with the basics. Actually, no. Let me start a new one. Why load that one with so many code that we cannot see? So let's see also how to remove at the beginning, and perhaps we have another array. Let me define another array. Let me put letters this time. A, B, C. Just 3. Too much typing otherwise. And let's see how we remove the first element. So we saw to remove the last one, we use pop. To remove one in the middle, we use splice. Can we remove the first one? Well, for this one, of course, we can also use splice and pass the index 0, but there's also another more useful command, which is called shift. Just like that. And if we run it, oh, we have to print the array. Let's use this notation because it's faster in this case. So we're gonna print all the elements really quickly. We'll run it. We should see just BC because we remove it. And exactly like with pop, we actually can take the first element in a variable such as x. So if we need the first element after we remove it or to know its value, we can basically take it in a variable. So let's just print that one for a second. See, it was A. Right. So this is how we remove it at the beginning. Let's do a simple exercise instead of this one. Let's write a function. Let's write a function to rotate this array to the left. Function rotate left. And let's say this function takes an array as an argument, which when we're going to invoke the function, we're going to pass this one. So how do we intend to use to basically use this function? We want to invoke it something like this, rotate left, and we're gonna pass the array, and we are expecting that if we're gonna run it, and this one will execute correctly, A to basically be shifted to the left and come at the end of the list, so to see BCA. But right now if I'm running is ABC. So how can we make this one? Very simple. We do shift, we remove the first element, and we use push, and we push it at the end. So let's do that. So let's take it in a variable this time. Perhaps that element is EL. And since we are in a function in a different scope, we can use the same variable as here. It's totally fine. So let's use ar.shift. We took the element. After this operation in the array, we have just BC, but we're gonna use now ar push, and we are pushing it at the end. So let's run it now, and we should see BCA. Now, if this would have contained more elements, all would have been just rotated one position to the left. And if we are invoking twice the function, we should see basically A comes here, and then B, CAB? Yeah, CAB. So each time we invoke this function, the array gets rotated to the left. So this is how you use shift and push to basically work with those first and last elements. Let's do the opposite function now. Function rotate right, and also takes an array as an argument. And if we are rotating right, imagine like you are imagining on the paper, this one, C needs to go out and be put here in front of the list. So it's easy to take it out. We know about pop, so we can say ar.pop. All right, so we are taking C out. How can we coming and put it here in front of the list? Very simple. Ar, the method is called unshift. Unshift. See, shift moves it, the element out, unshift brings it back. So unshift, and we put their element AR. So let's not do rotate left, let's do rotate right. So what should I expect? We should see C coming here in front. You should see cab. Yep. Now, if we rotate once left and once right, they should cancel each other. We should not see anything, right? Yep, so we should see ABC, which is fine. So let's name this one rotate arrays. Just some fun examples. Of course, as I mentioned, even the terminology stands for push and pop because they work with the top of the array or with the end of the array here. They are very useful when you are simulating stacks with an array. With a stack, it's a type of data structure. You are putting elements on top and then you're removing them. And the last element, the first element that you push is the last one that you remove, because you push, 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 and then when you start to pop them, you pop them in the other order. So the last one that you pushed is the first one you're gonna pop. And shift and unshift work with this array, and it's simulating a list where you basically the order is different. So you're shifting elements out and unshifting them from the other end. All right. So did I share this one with you in the chat? I think not. Let me share this one with you. So this is rotating arrays. And now, one tip of advice. When you are working or when you are coding, all you have to do is basically learn the basic syntax and perhaps a couple of useful or common functions or common methods. Those you need to know them on top of your head. The rest, usually you are accessing them from a reference documentation, right? Exactly like you're looking up a word in a dictionary. You are not an walking dictionary. You should not know all the methods and all the properties of an array. You should know about their existence, or you should know that, well, that may be something that can be possible with, and you should look into this. And there are plenty of documentation sources on internet about finding out methods of arrays. These are the called, so you should see what else other than shift and pop and unshift and push are available. We're also planning perhaps to do a second lesson to introduce a second set of methods which are more advanced, but those require different kind of approach to problems, so we're gonna handle them in a separate lesson. Meanwhile, if you're curious about what other methods are there, I want to show you something here. Yeah, perhaps also on CodeGuppy website. So let me browse here to a section and open this one, array methods. It's kind of a tutorial with a small playground. So as you go through it like that, it will show you various properties of an array. Okay, how to define an array, how to obtain the length of an array, and basically you have run button next to each example, so you can run it, see it, even modify it here, play with it, how to append at the end, how to insert at the beginning. And I think this basically this tutorial contains more methods, listed more methods and properties than what we did today. So, but as I mentioned, the goal is not to have your to turn you into an walking dictionary. You'll just, if you want, you can access them from here. Look, how to remove all the elements of an array and things like that nature. So refer to this one. For now, however, I believe it will be more beneficial to do a little bit more exercises with arrays just to get the sense of them a little bit better. Okay? So let's do a few more practical examples, to say like that. All right, I'm starting a new code here, and I'm intending now to do a small program to calculate the sum of elements in an array. So since we are talking about sum of elements of an array, we are basically starting with an array of numbers, right? So let's have here some numbers, even negative numbers, something like that. And now we need a function sum that takes as an argument an array and will calculate the sum of numbers inside this array. And this will basically give you a sense for some real world problems that you can encounter when working with arrays, rather than just knowing their properties. So we're gonna use this function. The way we want to use this function is basically we want to take in a variable, perhaps s, we'll say sum of this particular array, and then we're gonna print the sum, right? So how can we build this function? We made the function with accept a parameter, so rather than using this global array, it's actually taking the one that is passed at the invocation, which is the same in this case. But nevertheless, it's good practice to parameterize functions rather than read global data inside. So the way we're gonna do it, we're gonna do it the same as we did. Let's name this one sum array, because we may have clashing with so many sum and sum, and then this variable can have a proper name. Okay. All right. So the function is named sum array. Let's have a variable inside named sum, which again we can, and this variable inside is different than the variable outside. This is in a totally different scope. We discussed about scope. If we don't define the variable here inside, if we don't put a let, basically we're gonna access the one outside the function, but we'll put a let just to have a new one here. So and exactly like we did the sum of numbers from 1 to 10, where basically we cycle through the numbers and add them. This time we are cycling to the elements of the array. Okay, so we're gonna use, well, in this case we can also use the other form, like this one, and we are summing that particular element, and we are returning the sum here. So if we run it, answer is 150, which I hope it's okay, because I choose some numbers that I don't plan to calculate myself right now. So this is okay. We did the sum of numbers in an array, sum of numbers in array. I'll share it with you. All right. So perhaps let's build a few more functions inside this one. So rather than having this one, sum of numbers, array function, array, playing with arrays. Let's name it like that. So this is a useful function. Each time you have this task to calculate the sum of numbers, just build something similar to this one. Let's build another function that will basically return the minimum or maximum number in an array. Let's say function, perhaps find max. We'll also receive an array as an argument, and basically if we are looking at this array, we should expect, if we are running, we should see 53 here. So let's see how we approach this problem here. How can we find the maximum number? And we're gonna use a simple algorithm. We're gonna cycle through all the numbers. Actually, we're gonna start at the beginning, and we'll assume the first one is the maximum. We'll just make an assumption. We are looking at the first one and say, okay, I believe this one is the maximum. But nevertheless, we'll continue scanning, and we'll compare each and every other element that we encounter with the one that we picked as being maximum. And if that one is bigger than the actual we picked, we replace the one that we picked with that one, and we have a new maximum. All right. So we're gonna say max. It's array of 0, the very first element in the array. And then we're gonna do a for loop. Let's do it based on index, because we cannot use the other form of for. So we'll have I start at 1. We don't start at 0, because 0 we already took it. So we need to start at the next one here. I less than ar.length, I plus plus. And now we do the comparison. We compare if array at this position, if it's greater than our maximum, basically the one that we picked, well, in this case, we pick a new maximum. We say maximum, it's array of I. And that's it. And we let it continue the for, because maybe we'll encounter a new max down the road. At the end of the for, after we'll finish looping to all the elements, basically in max we'll have the maximum. So let's return it, return max, and this is our function. Let's move it up. Actually, we can leave it here. This is our function, and let's invoke it. So first one, let's change this form a little bit. The first one is sum, and now the second one is max, and instead of sum array we invoke find max. All right, let's invoke it. 53, it is correct. What if after 53 somewhere here it was another maximum, 100? Let's see if we get 100. It's 100. It is correct, because the for continues till the end. So even after it finds the first maximum, the for continues, and if it encounters another number that is bigger than that one, it picks that one. So this is correct. One more example. What if we make a function to filter this array and return only the positive numbers? And again, we're gonna do it like coding for beginners. There are other ways of doing this one, and more advanced programmers, if anybody watches, will see that we are using a simple method, but at this stage of the game, it's much better. It's better to use simpler methods than using things that we don't yet know. So let's make a function named getPositives that will basically take an array as an argument. And now this function, what we plan to do, we plan to loop through the initial array, to the array that we receive as an argument. And if the number is greater than 0, we want to put it in a temporary array. So we want to build a small list inside that will be initially empty. And we loop on the original list, and each time we encounter a positive number, we put it in this list. And at the end of the function, we return this list, which should contain only positive numbers. All right? So let's do that one. We can do using this form, because we cycle through all the elements. Let's define an empty list here. So we're gonna define empty or array positives. I picked a bigger name, and I'm starting with an empty list. Remember this syntax for empty lists. So we are looping through all the elements, and we can say here basically, let's say, yeah, positives, basically greater than 0, 0 not included. If EL is greater than 0, so in this case, all we have to do is say AR positives, push element. We are pushing into two other lists. We are adding at the end, but basically doing this, we basically fill the list one by one. And at the end of the function here, we are returning AR positives. Pretty easy, right? Let's test it. So the function is called getPositives. Now notice something. This one is basically not returning a single number, is returning an array. So we are using println to print an array, but I think println is handling this this situation. All right. So notice, these are all numbers from the original array, but all these are positive numbers. So basically the function worked. And it's always good to comment out these functions. So this one, get the sum of elements in the array. This one returns the maximum number in the array. And this one returns a new array with only positive numbers, basically from that array that we are using. All right, so this is how basically you use these very simple and basic methods about arrays. I hope that you basically kind of, you know, don't find them difficult. So let's now build a little bit more, some more interactive programs. I'm thinking of something graphical this time. Do you like graphic things? I hope so. So look what I did. Ta-da! See this guy? I found it in a very old, probably from the 80s, coding book. Back then where books, they used to teach basic to beginners. Anyway, that image represents a sprite, and actually I'm gonna explain it to you what it is. It's back in the days, people used to define these sprites on paper, on graph paper, and in this way they used to define graphics for video games. So they draw the graphics on paper, and then they encode it in the code, and they build just, you know, nice graphics and things like that. So that's what that thing is. It's a sprite, and right now we're gonna use that one as an excuse to encode it in our code, practice arrays, and, you know, maybe even give you some ideas about how to how to do this in the code. Maybe you want to build a game sometimes in the future. Yeah, who knows? So let me show you how we're gonna encode that guy in the code. Let me switch here to my notebook. So I'm planning here actually to draw an 8x8 kind of grid like that, and the same here. Bear with me a second. So here I try to do it as nicely as possible. So I'm gonna draw these lines, these vertical lines, just like that. So in other words, what I'm doing here, I'm designing on paper an 8x8 sprite, or in other words, a small 8x8 pixel bitmap. We can also say like that. So, and the way you can basically do this on paper, if in the future we're gonna design maybe characters for our games, you know, just define a grid of whatever size and then draw your character. One more line. So that character, in order to encode it here, let me pick a different color perhaps. You know, you just start coloring these squares here. So perhaps I want to have that spider in my code. So I'm gonna color these squares like that. And perhaps the second row I'm gonna color like that. And yeah. If you don't have, if you're not graphically inclined, just partner with somebody that will draw the graphics for a game, and then you just write the code, and you'll continue like that. Perhaps this one, I think it's 5. Yeah, 2, 3, 4, 5 here, and we'll have it the same. So see, just doing like that, we can design new graphic characters. But the question will be, and actually I'm not finishing this one, I'm just showing you an idea how to do this, guys, because I have mine already on a grid paper, which is 8x8. So they are 8 square like that and 8 square like that. And what we're gonna do, we want to encode this in an array basically. And for each square that is not colored, we're gonna put a 0, number 0, and for each one that is colored, we're gonna put a 1. So this is 1, 1, 1, 0, 0, and so on and so forth. So basically, our array will look something like this. We're gonna define one array for each row, and then comma, and then the next row. So we'll have a big array that opens here and closes somewhere at the bottom, like here. And inside this one, we'll have several other arrays, just like that. As a matter of fact, we will have 8 arrays, right? And in each element, in each of these arrays, 8 elements. So we'll have 0, 0 here, 1, 1, 1, 1, 0, 0. So that will be the first row. So encode all the rows like this. All right. So let me switch to my computer here, and I'm gonna try to encode really quickly this image that I have here, this structure, in an array on the computer, and see how we can manipulate it and perhaps even display it, right? So let's see what we can achieve with this one. I'm going back in the code. I'm defining an array. Let's name it spider, not AR, like I put there. And you know, I'm opening and closing the array, that I can just press some enters and do it on different lines, because I want on each line to have the rows actually. And the first one is 0, 0, 1, 1, 1, 1 for ones, 0, 0. I'm looking here on my paper with the spider and try not to miss anything. The second one should be 0, then 5 ones, no, 1, 2, 3, 4, 5, 6 ones, and then a 0 here. Okay, third row, almost there. 1, 1, 0, 1, 1, 0, 1, 1. Oops, maybe we need a comma. Yep, I think I put them all of them. If not, you know, our spider will not look nice, as nothing bad will happen. Like that. And the other row, it's 1 0 1 1 1 1 0 1. All right. The other one, let me see which is this one. It should be this one. 1 0 1 0 0 1 0 1. Cool. The other one should be the same, so I'm gonna copy this one, and I think I have one more row, and that's it. So it should be 0 0 1 0 0 1 0 0. Okay, let me count them. 2 4 6 8. All right. So what we have in here is basically an array, right? You can also say about this one, it's an array of arrays, because each element is an array. We can say it's an array of arrays. Also, because it's kind of 2D, this array is also recognized or can be referred as a 2D array. Some languages have a pretty strict syntax how to define 2D arrays. In JavaScript, it's pretty flexible, so you just define it as an array of arrays. All right, so let me name this one spider. And what we have to do right now, first of all, I'll run it. We have no errors here. What we have to do right now is to print the spider. Let's see if we can print it, right? So we're gonna create a function. And why print it? Well, first of all, if we do like this, we can define our own characters in code. And basically, even if we are running in an environment that doesn't have built-in characters, here on codegrappy.com we have this beautifully animated built-in characters, but nevertheless we can still define characters in code and basically be like programmers in the 80s. Perhaps we are building a retro game, so we want to define retro graphics. We can do like that. Or perhaps we are on a different platform that doesn't contain built-in graphics and we don't have any chance to import graphics. We can still define it in our code, first on paper, then we transfer it in code. All right, so let's create a function here. Print. Let's say maybe this is a sprite. Print sprite. I don't know. Print sprite. That will take the actual sprite and an X and Y where we want to print it. All right, and when we're gonna invoke it, we're gonna say print sprite. We print spider. Perhaps at 100 and 100, somewhere here, at some coordinates, right? So let's see how we print this sprite. We need to loop, first of all, through each and every row and then each and every column. Since this looks like a 2D structure, like the canvas, we used a nested for loop. So let's say for let row equals 0, row less than. How many rows? Well, we can put 8 if we want, or we can say spr.length. Since this spider array has actually 8 elements, which are these 8 subarrays, so this should give us 8. Row plus plus. Perhaps we should take in a variable AR that particular row, so it's spr of row. Yes, so at this moment in AR variable we have each row. Perhaps we can take it or not, doesn't matter. For let call equals 0, call less than, and now if we have a particular row in a variable, we can say length of that row. Although it's 8 again, we know about that one. We don't have necessary to do this one. And now we need to define it, right? To plot it. Question is, how big should we plot? If we encounter a 0 or a 1, we should put a block on the screen, right? But how big the blocks are? On my paper I have gigantic blocks. Do we want gigantic blocks or smaller blocks? Let's define a constant here, a global constant. We'll not use it as a parameter, maybe dot size. Maybe 16. We'll start with 16. Let's say this is the, we are plotting these dots and this is the dot size, right? So And the way I'm thinking to plot these dots is not with a single pixel, that's why we also have this content, but with some filled rectangles. So we have some really chunky sprites on the screen. So the question will be basically what will be the x and y coordinate of this rectangle and then what will be the x and y coordinate of the other one and x and y of the other one. And they're very easy to calculate because we know the dot size. So this will be the dot size. So this one and this one, they have the same length, so but that's dot size. So we can multiply the column with the dot size and we find the y or the x, something like that. All right, so should be pretty trivial to calculate that. So that should be so we printed x and y. I want to print it at x and y. Let's name this one sprx and spry, where we want to place the sprite. Maybe sprx uppercase and spry. So this will allow us to pick x and y for the individual dots. We could have picked different variables, but I think it's nicer this way. So x, basically, because we want to print the sprite at sprx, it's sprx, but it's not there. It's depending on the number of the dots. So it's also call multiplied by dot size, right? And then the same for y, it's spry on vertical, and it's row multiplied by the dot size. All right, so we know now the x and y of each individual square, but we only have to do this. We can say here like this. If AR, now because AR contains an individual row, if AR of call equal with 1, only if basically it's a 1 in there, we want to draw a rectangle. So we calculate x and y. We're gonna use a fill. Perhaps we can use, let's use it as a constant here. Fill color, I don't know. Let's use it black for now, or maroon. I don't know, what colors are spiders? Fill color, let's say fill color. Here we'll fill with fill color, and then we'll have a rectangle at x and y, and size will be dot size. All right, our functions looks correct. And actually we're invoking it already. Let's save the program and run it, and we have a spider. Well, and we have also the small rectangle. Let's print also the white rectangles just to see them. So perhaps you know what, make the x and y outside. Let's print also the white ones. So, and the thing will be like this. We're gonna say here, if it's 1, we fill with that color, otherwise we fill with white, and then we have the rectangle, and I think we have an extra, yeah, I had an extra one. There's a simpler way to express this one, but we'll learn in the future how to do it. For now, let's run it. Yeah! We have also the empty ones. So let's increase the dot size, 32. Well, see, we have a bigger character. But now we don't need to see those lines at all, actually. Why see those lines? We want to make this up a nice sprite, perhaps in a game. So we don't want to see those. Let's make the code back at how it was. We'll take x and y in here, we fill with that color, we make the rect. Only in that case we can even say no stroke, because we want to see just the filling, and looks like that. And perhaps we should see smaller, and let's do just a spider following the mouse cursor. So we'll put a function loop here, and inside the function loop we can clear the screen, and we just invoke the function here. Oops, but not at 100 or 100, but at mouse X and mouse Y. Let's see it. Yay! So you know what arrays are also good for? To create an array of these spiders. So instead of one spider, maybe you can have multiple spiders on the screen. We can do that with an array. We can place multiple spiders in an array and they can just be there jumping on the screen. But let's not overcomplicate this program too much. I leave it like that. And still we can play a little bit more with arrays, perhaps use arrays and place other things in the array. So let me place this one on the chat. Spider. But feel free, you know, extend this program, you know, even think of a game to use custom drawn sprites, spiders and ships and planes, and you know, it's up to you what you want to invent there. All right, let me start another program because I want to do something a little bit different this time. Of course, we're gonna use arrays because these are for the topic of today's lesson. But let me start here Paint, and I'm gonna show you what I want to build. All right, so you know, a paint, the pretty basic paint application. It has these shapes here. Perhaps I should choose a circle, and you know, I can draw circles basically. See, so I'm doing a circle. You know, let's do this one in the code. Let's see how can we draw circles like that with the mouse in a program. And what we want to do is basically keep track of all the drawn circle in an array, because if you pay close attention here at this moment on the screen, there are these circles that are already drawn, and it may be or not another circle that is about to be drawn, like this one that I'm right now manipulating with the mouse. So what I want to do, in the moment I'm gonna define a circle with the mouse like that, and when I'm gonna release the mouse cursor, I want to add this circle also to that array of circles. So yeah, let's do this this exercise, shall we? So let's have a function loop. First of all, we want to define because this will be like a smooth animation. When we are resizing that circle, we're actually clearing the screen and redrawing everything. We're gonna just define a function define a function loop inside here. And all right, what should we do here? Yeah, let's define an array of circles. Let's name this one AR circles. That will basically contain a series of circles. These are the circles already drawn. And what do we have to keep for each circle? For each circle, we need to keep the center and the radius, right? So actually inside this array will be, like in the case of the spider, subarray. So let's pick an example. Let's choose one. Let's say if we have a circle at 100, 100 and center 100, 100 and radius 100, we'll have this array, right? Subarray, this element array inside this array. Therefore, we need a function display circles that basically will loop through all these elements in the array and will display them. And as we said, we are growing this array in time because we're gonna draw new ones. So let's display first one, these ones. And I put here a test element to see them. So we're gonna go for each, for let C from circle of R circles. And now C, it's a subarray, right? So we're gonna do circle C of 0, C of 1, and C of 2. Because C represents the subarray, C of 0 represents the first element, the second, of 1 the second one, and the C of 2 the third one. So let's invoke the function. Let's see if it's working. We'll also have a clear because we won't plan to do this in a loop. Clear and redisplay them. Okay, we get one circle. If we'll have two circles somehow at different coordinates, perhaps one at 300 or 400 and the other one there. Yes, we have two circles. So our code works correctly here. Let's have it empty. Yeah, it's nothing. So this function is good. But we also need to basically draw what we mentioned, to draw that circle with the mouse click somewhere and kind of define a circle with the mouse, right? So we're gonna use a mouse pressed function. So mouse press, we press with the mouse, we define the circle, and then we're gonna need the mouse released function to basically specify that we finished the circle. And refer to the lesson from yesterday about these functions. So function mouse released. And what is happening when we are pressing the mouse, we want to record where did we press the mouse. So let's have some variables here. Let x, let y. We don't assign any values to those, but what we're gonna do, when we press the mouse, we say x equal mouse x, we record those values, and y is mouse y. So we record where we press the mouse, right? That's it. And then we want to display that one. So all right, we should also have, like we have here, display circles. We should have a function to display the circle, the current circle. So let's have a Boolean variable that will specify if we are in drawing mode. Drawing mode, and let's say we are false initially because we are not drawing anything. In the moment we click inside, we go inside the drawing mode. Yeah, this is the algorithm. In the moment we click on the canvas, we go in drawing mode, and we record where we started the coordinates. And when we release the mouse, drawing mode becomes again false, right? And now we need a function that basically display current circle is the circle that we are dragging with the mouse. So what we're gonna do, we're gonna draw a circle from the recorded coordinates x and y, not from the mouse x and mouse y, but from the original ones that we recorded when we pressed first the mouse button, and of certain radius r. The question is, what is the radius r? And radius r is very easy to calculate actually. So what is happening is this. Okay, look, this is our canvas, and we are going with our mouse pointer here, and we say click, and we click in this point, and in this moment we drag the mouse cursor and we arrive in another point. What we want to see drawn a circle here like that, right? Until we release the mouse. Therefore the center will be initially where we press the mouse, so that's x and y, where we initially press the mouse, and we record this in the mouse pressed button. And then we need to figure out this radius. Well, this radius is actually the distance between x and y and this point, which is the mouse x and mouse y coordinate, the current one, mouse x and mouse y. And we work with the distance last time. All right, so we need to figure out the radius, and we'll be able to draw this circle very easily after that. So let's figure out the radius. The radius is the distance between point x and y that we recorded and mouse x and mouse y. And then we can draw the circle here. Let's see if it's working. Click, nothing happens. Oh, because we are not invoking the function. But this function, we should invoke it from the loop, but not all the time. So it should display the existing circles, but this one only if drawing mode. Only in this case we display the current circle, right? So let's draw it. Oops, when I'm releasing, it disappears. So I click, see that circle appears. I can make it bigger or smaller. When I release, the circle disappears because it goes outside of this mode. Let me show you a trick before we're gonna see how to persist that one. Instead of doing here this if drawing mode, run this function, we can always run it like that. We display all the circles, then we try to display the current circle, but inside here we say if not drawing mode, If we are not in the drawing mode, return. So we are trying to invoke the function, but immediately when we go inside the function, if we are not in drawing mode, we cancel the execution. Sometimes it's, you know, just keep in mind this kind of technique. All right, so what we have to do now is when we release the mouse, we have to add into that array this circle that we just defined, and everything should be fine. So we are going in mouse released here, and when we are releasing, we go outside of the drawing mode, but what is our array named? AR circles. We can say AR circles dot push, and now we are pushing a small array made out of X and Y. The coordinates, we do start the circle to define, and we need to push also the radius R. Well, we can take that in a separate global variable, or we can just recalculate it again like we did here. Distance between X and Y and the current mouse position. So by adding it dynamically inside this array will be looped through by the display circles, and we expect those circles to appear on the screen. So let's name this one draw circles, like that. We'll save it and we'll run it, and voila, we have circles that they are persisted on the screen. And you know what, perhaps we can, the current circle, we can display it with a different color than the other one. So what we can do here, we can say stroke, perhaps this one will display it with light gray, because we want to look a little bit you know, lighter, and this one, let's say it, the other ones will be stroke black, or we can choose different colors. Yeah, so light gray, boom, it appeared. Light gray. See? All right, looks pretty cool. So what we can do right now, we can do like we did yesterday. We can make this program generate a source code, or we press a key of a program that will do the same drawing. Shall we? Let's do. So perhaps we should handle here, let's do it at the end, because right now we don't care. This logic is related about drawing, but we can have a function key pressed, and we don't care which key, any key. In the moment we generate, we click a key, we want to generate the program. But we'll do it a little bit different than yesterday. Rather than actually generating the code line by line at the moment we draw, we don't have to do that. Since we have all the coordinates already in an array, we can just use this array to generate the code. So what we can do, we can loop through that array for let circle of AR circles, I think it's called, right? We can have the variable here equal empty string. We loop through this array, and what we can do, we can say code, and now we concatenate to the code circle like that, and then we c of 0 plus we put a comma plus c of 1 plus we put comma plus c of 2. This is the radius plus we close, we put, and we put an enter. Something like that. And now we can print the code on the screen. Hopefully we don't have any mistake. Let's save it again, run it, and draw something nice. Hopefully something nice. And hopefully we don't have a mistake. I don't know if this is nice to you. I do my best. It looks like the bear, you know. I'm trying to reproduce the... Oh, that's a big ear. I'm trying to reproduce the bear that we draw with code in the first lesson. All right, so let's press any key. And we got this code. We forgot to round up the decimals, but let's just copy the code. We'll close this one. Let's go right now in a new page of code. We paste the code here. Run it. And we have a bear generator. All right, so perhaps here, like we did last time, we can do floor like that. just like that. And now the program should look much cleaner because we don't have to place decimal numbers inside there. So let's try. Yeah, it looks much cleaner. All right, so that's one way to generate the code. We could have generated differently though. I'm thinking maybe another method to generate this one would be, yeah, I'm doing a time check here really quickly. Yeah, let me generate it differently. Also, just to give a little bit of a different flavor to this one. We still have a little bit of time. So instead of adding this instruction to the code, what we can do, I'm gonna comment all together this one. We can start with the code as being something like this. Let AR equal, we put a semicolon, and then we're gonna cycle through all the circles, and inside of AR we're gonna put code plus equal, and I want to put basically this guy plus C of 0, or basically these things until here, all these guys plus square bracket, comma. All right, so I place all of these numbers inside that code, and I can say now, and here I can place an enter just to have things much clearer. And here we can have an enter. They are not needed. And now code plus equal, and we can close that array, and we can have an enter and enter. It looks more complicated, but yeah. So let's have, also we need to add to the code something else. We need to add, it's like we are looping through the code. C of AR, and I'm gonna try to type everything in one line, although it doesn't look nice. Circle AR or C of 0, C of 1, and C of 2. This time inside the string, just like that. All right, let me print the code and see if I did something good or bad here. I'm drawing one circle, two circles, three circles, these circles. Press a letter. All right, so I got this small snippet of code that I'm copying. So I intended basically to, instead of generating the program line by line with circles, I generated a program that contains an array, and then it also contains the logic to loop to that array and display it. So I'm not sure why I have an error here. Probably I didn't close. Yep, I forgot to close a parenthesis when I generated this. But supposing we close that one, and if we run it, we obtain the same effect. So yeah, this is version 2 or another possibility to generate code. Let's put here v2, and this one will be v1. So let me save this one on the chat. In the interest of time, I'm not beautifying this one. I let to you as an exercise to beautify it, and also to go through the code and really understand how all these concatenations work. But I hope that you like the exercise nevertheless. Let me see here, draw with circles. And one more exercise for today before we wrap up the lesson. I want to make it snow, so let's make it. I'm starting with a function, mouse pressed, and basically I want, each time I'm clicking on the screen, for instance, I want to draw an emoji. First of all, let me show you what I want to build. Text, an emoji, which is snowflake, this guy, that coordinates mouse X and mouse Y, something like that. So if I'll do this thing right now, oh, the snowflake is very, very tiny. Let's increase the size. 60. Yep, we have some snowflakes, which are actually emojis. So let me take this guy in a constant, because the editor sometimes misbehave when I'm using it. Let or const snowflake equal this, and now I can basically just don't use that one, but use the constant. Yeah, like that. But I don't want to just leave the snowflakes there on the screen. I want them to fall. So in order to do that, what I'm gonna do, each time I'm clicking on the screen, I'm gonna place them in an array, and then inside the loop function, I'm looping through the array and make all the elements go down it a little bit. All right, so that will be the logic here. So let's have an array. Let snowflakes. It's an empty array. We'll also have a function loop that basically we're gonna loop through this array and display them. So for each snowflake, for each element of snowflakes, what we're gonna do, we're gonna display it basically. So let's take it in a separate function display. So we are looping through all of this, and for each of them we're gonna do something that it says it's similar to this one. We display what the all right, so what do we need? Let's think, what do we need to store for each snowflake? We need to store the X and Y position first of all. That will be the most important one. Yeah, let's store just the X and Y position for now. So basically in each of these arrays will be sub-arrays with an X and Y, basically like these numbers, like that, right? So we store X and Y positions inside this array. So because we do this one, we are going here and we are displaying snowflakes at element of 0 being X and element of 1 being the Y, right? So when we press the mouse, we actually inside the snowflakes array, we are adding the last element and sub-array, which is mouse X and mouse Y, right? So when we press the mouse, we push, and then this guy is displaying them constantly. Let's clear the screen and call this function. So supposedly should be the same effect as before, right? But the logic is different. Basically mouse press is not displaying anything, but rather is pushing in this array, and then this array is scanned really, really quickly and then displayed. So all we have to do now is create another function. Perhaps we should name it update. That will also cycle through all these elements in the array. Let's invoke it after we display it, and we'll make them go down a little bit, right? So yeah, this time let's use a for with an index, and more than that, let's loop the array backwards, because once the snowflakes will go outside of the screen, we want to remove them. So let's start an I that is going from, what is the variable name? Snowflakes. From snowflakes dot length -1. This is the last element. I greater or equal than 0. I minus minus. So we are looping to the array in the inverse order. And now it's an element of the array will be basically snowflakes of I, right? So that will be the element X and Y position. So what we have to do right now, we have to go element Y. This will be Y minus minus. Are we correct? We're correct, but they fly in the different direction. So it's plus plus. So YEL1. So until here is basically the this is the EL of 0 we store the x, and in EL of 1 we store the y coordinate. So we are basically increasing that the value of that one. So this one is EL plus plus is similar to saying again EL1 plus 1. It's the same. So basically we are putting inside EL of 1 these guys here, right? So now they flow in the correct direction. So that is fine. But yeah, that is fine. I can put plus plus here. It's a short notation. You can get used to this one. But now let's do one more thing here. We can check if EL of 1 is bigger than 600. What we can do, we can remove it. So we can have the snowflakes array, basically. That's the way to invoke it on the array. We call the splice method at index I, and we'll remove just one, right? So let's see, once they go outside, the program should not crash. It's not crashing, but how can we know if we have the right elements? So let's go here and let's put a small text here in the top left corner. Let's display how many elements do we have in this array. So in this element, we're gonna display the length of the array, perhaps at these coordinates, right? And text size, let's make it 12, something like that. Let's run it. Is 0 because once we click, we have 1, 2, 3. So we add it in the array. Let's see if the number gets down once the snowflakes disappear. 2, 1, 0. Right. So the splice is also working correctly. It would have been a shame if that splice wouldn't work correctly, because we would have created kind of a memory issue. The memory would have grown and grown and would have what is called a memory leak. And we didn't know where the memory is going. Probably wouldn't notice in this small program, but in bigger applications, you definitely can notice. So let this know. Now, what we can do, we can also assign, in the moment we create a snowflake, we can assign basically a certain speed. So let's do that really quick, just really quick, and we'll have to close for today. So when we are adding an element, we are recording the coordinate x and y, and let's record also the speed. And for this one will be a random number between 1 and perhaps 3 or 5. That will be the speed. So now we are not increasing by 1, but we are actually increasing by element of 3. So 0, 1, oh, of 2, right? 0 is, in this array we have 0, index 1, index 2. So we are increasing the y position by the value in the other element. So let's see how it looks like. These are so fast. Let's make a random between 1 and 3. Now see, some are faster than the others. Let this know. I'm clicking here. Let me see if I can give them a different color. And basically we are almost done with the program. Let's see if I can have a fill of blue. Blue? Snowflakes are blue? No? Yeah, they are blue, but you know what? No, let's let's pick a winter theme, perhaps this one, winter night. Let's pick a winter night here, and now let's make them white, because white will be able to see them better. Where is that blue? Where I put the blue? Blue here. All right, let's trim them by white, and let's have no stroke, just like that. Stroke. I think will look nicer with no stroke. Yep. Let this know. And all this was achieved using simple arrays. Arrays are very useful, right? We can use in plenty of games and applications. All right, I think it's time to wrap up the lesson. Let me share this one with you. It's named Snowflakes. I'll save it. I wrote all this code that didn't save. I risk it, but it's not good. Snowflakes. The program is on the chat, and I hope that you had fun today. And Thank you again for watching. I wish you to do lots of practice. Happy coding, and we'll see you next time. All right. Happy coding.